Guys, how are you? Welcome to Nostec Academy. In this video, I'm going to give you the guide. Okay, you may call it the predictions. Okay, predictions, something like that. But I'm going to give you the focus so that you know where to concentrate as you be studying. Okay, so that you don't get disappointed as you be writing your chemistry on Monday. Let's get started. As I'll be explaining, if you feel like this content is of value to you, please consider subscribing. Also, like the video, give us a comment, and also you can share to your friend who is also writing. That's the only way you can help us grow. You can help the channel grow. So the information that we are giving to you, please share it with with your friends also. Okay, that's how life is. We are here for each other. I'm helping you. You also need to help someone who may need this information. By the way, only share, only comment, and only like if this is giving you value or is of helpful to you. Let's get started. Chemistry, which is science paper 2, is divided into three sections. Section A, Section B, and Section C. There. Okay? Section A, these are multiple choice questions. Section A are multiple choice what? Multiple choice questions. All right? There are 20 of them. All right? 20 questions. Section B. Section B is, so this is 20 questions. Let me just write the number of marks. This is 20 marks. This is 45 marks. This is 20 marks in section C. 20 marks as well. Okay, listen and listen very carefully, my good friends. Section A, these are multiple choice questions. Okay, multiple choice questions 1 to 20. 1 to 20. 1 to 20 questions. Okay, and these questions, they come from almost all the topics from grade 10 to grade 12. Okay, almost in all the topics. The first two questions, they come from grade 10, from the introduction, where you have branches of chemistry, you have the importance of chemistry, you also have what's this, laboratory safety rules, you also have apparatus in the laboratories, okay, something like that. You also go to matter, changes of state of matter. So question 1 to 20. The last two questions, maybe 19 and 20 or 18 to 20, is organic chemistry. Okay, organic chemistry. So section A to 1 to section A 1 to 20, question 1 to 20, almost all the topics come. So let's go to section B. That's where the issue is. Section B is 45 marks. Section B is 45 marks. Now, these are the topics that you should expect in section B. Okay? The topics that you should expect in section B. The first one, let me just write state of matter. I would have written kinetic theory of matter. Okay, states of matter or kinetic theory of matter. Now, under states of matter, they may bring the kinetic theory of matter. You to explain the kinetic theory of matter, okay, you should know that the kinetic theory of matter states that matter is made up of 10 particles that are in continuous random motion. Okay, this experiment was carried out by Robert Brown. The experiment, which is later known as the Brownian motion. Now, the changes of state of matter you need to know. So we have solid, liquid, and gas. These are states of what? These are states of matter. Solid, liquid, and the gas. You also need to know basic units of matter. The ions, the atoms, and the molecules. You need to know them. Okay? Now, you need to know what change of states takes place or when solid changes to liquid. Okay? When liquid changes to gas and vice versa. When gas changes to liquid, liquid to solid. And also the direct change of state of matter from solid to direct to gas and gas to solid. You need to know that. Okay? So I'm just explaining here, but the questions and the answers, examination questions, are there on the video list and also will be posted very soon. Okay? After this video, the videos will be posted in accordance to what I'm explaining so that on Monday you even benefit as well. Now, what else should you expect when you under states of matter? You should expect the properties of matter. The properties of matter, properties of solid. When you look at a solid substance, do I have an example? An example of this one. This is a marker, a solid substance. What are the properties? In terms of volume, it has fixed volume. In terms of occupying space, okay. In terms of shape, it has a fixed shape, okay. So in terms of compressibility, it is incompressible. You can't compress, okay. You can't compress a solid substance. It's incompressible. The other thing is that the particles arrangement. How are particles arranged in solid substance? Remember I said that it is incompressible. The reason is because particles are closely packed. Are arranged in a regular pattern, okay? In a regular pattern. Shouldn't be explaining much, but anyway, you understand. Closely packed in a regular pattern. Is it visible? Closely packed in a regular pattern? No. I'll tag them. I'll tag examples of questions so that I don't want to make this video too long. Okay. I'll be tagging the examples of questions like I did in mathematics with mathematics paper 2. Okay. So that you understand, because sometimes you may get confused with liquid and gas, like that question which should be 2009-2010 somewhere there, where all particles were closely packed in solid and liquid, but the only difference was in solid they were in regular pattern, in liquid randomly. How about particle movement? How do they move? They do not move. They vibrate in their fixed position. In their fixed positions, I mean. So you also do the same with liquid and gas. Okay, liquid and gas. You should also know the intermolecular forces of matter, forces of attraction. Sorry, intermolecular forces of of attraction. Listen, my friends. When you look at when it comes to matter, the last thing that you should expect, okay, is endothermic and exothermic reactions. Endothermic and exothermic reactions. Remember, this is the key. When you have solid, liquid, and gas, every direction, the arrow which is pointing towards the gas, from solid to gas, that is endothermic reaction. Let's use an ice as an example. For ice to change to liquid, it needs to absorb heat, endothermic. For liquid to change to gas, it needs to absorb heat, that is endothermic. Also, the sublimation from direct change of states of matter from solid to gas. From solid to gas, it is endothermic. From gas to solid, it is exothermic. So as you go back, the reverse is exothermic. I think that is the simplest way. A bonus. Know the differences between boiling and evaporation. Know the difference between boiling and evaporation. Know the heating curve and the cooling curve. I think that's all about the first question, usually the first question. Let's go to the next item. So the next item here, in section B, you need also to know separation techniques. Let me use methods. Separation what? Methods. Do yourself a favor by going through all of them. Let me mention some of them. There's filtration. There is also decantation, sedimentation, magnetism, fractional distillation, simple distillation, chromatography. Okay, these are the major. There's also crystallization, evaporation, crystallization, something like that. But these are the major ones. You need to know them, go through them, answer a number of examination questions, or maybe go through our videos, okay, so that you become familiar with what I'm talking about. Okay, go through them. Sometimes they may bring a list of these separation techniques or methods. Then you'll be asked, which separation technique is used to separate an insoluble so from so used to separate so from so, something like that. Okay, so you should be in a good position, even smiling, okay, in answering those questions if you've gone through them. Yeah, you should also know. Yeah, I think you should also know. I think that's so. Oh, by the way, the other thing is that you should also know the solutions, okay? Soluble, the meaning of soluble, insoluble, immiscible, and immiscible. Because for you to know the method of separation you're going to use, the criteria that you're going to use is it liquid? If the answer is yes, is it miscible or immiscible? Are we together? Is it miscible or immiscible? Now, if it is solid, you should ask yourself, is it soluble? Meaning, does it dissolve in water? Okay? If it's insoluble, it's a substance, a solid substance that does not what dissolve in water. Okay? Then miscible, these are liquids that do not mix, that mix completely. Miscible, like water and ethanol, an example. There is a method of separating those miscible liquids that mix completely, where you can't see that there is water there, that is water, that is ethanol. No. Then there is also immiscible, like I explained. Immiscible, it means liquids that do not mix completely, like water and oil. Okay? There's a separation technique that is used to separate those kinds of liquids as well. Listen. The other thing is number 3. No, these are ingredient topics, criteria of purity. Criteria of purity. Criteria of purity. You need to know the issue of when it comes to criteria of purity. Okay? This criteria of purity is very, very important. Why? You need to know the purity of substances such as food, medicine, and also lotion we apply on our bodies. If they're not pure, they're not pure, or they're expired. They may cause serious danger to human beings. They may cause serious illnesses, even death. Okay, so criteria of purity is very important. Now, what do you test? What do you determine for you to know that this one is pure or not pure? Talk of a boiling point. Something which is pure has sharp boiling point, something like that. Melting point also is fixed. Sharp melting point. In terms of density, it has fixed density. If you know that when this one is pure, it weighs, let's say, 2 kg, then suddenly it's weighing what? 10 kg. You should ask yourself, I think there's something wrong with this product. Okay? There's something wrong with this product. So, in food processing industries, cosmetics industries, they should make sure that their products are pure. Okay, that is under criteria of what? Purity. Touch that part as well. Okay, now let's go to the fourth one. Number 4, my good friends. Number 4, you should also know that the issue of bonding atoms. You should know the difference between an atom and an ion. Are we together? An atom and an ion, a compound and a mixture. You should know those differences. An atom and an ion, so that you don't get confused when they say sodium atom. Okay, let me write bonding here. When I write bonding, chemical bonding, I'll explain everything. When they say sodium atom, it means this one, Na1123, the mass number there. But sodium ion is different. Sodium ion is charged. It has lost what? 1 electron, and the number of electron is 10. It's no longer 11, 10, but the mass number is still 23. So you should know atom, but the difference between an atom and an ion. An atom is the smallest particle of an element, something like that. That is the basic definition. Okay. Then an ion, this is a charged particle. Then we have two types of ions. We have cations and ions. So a cation is a positively charged particle. An ion is a negatively charged particle, something like that. Okay, I think you understanding. Now, bonding here, you should know these 3 types of bondings. Please know they are there. One of them is there, ionic bonding, which is also known as electrovalent bonding, the bonding between metals and non-metals. Okay, it involves transferring of electrons. Okay, metals and non-metals. You should also know the covalent bonding, which is the sharing of electrons. This usually takes place between non-metals. An example of covalent bonding, you have carbon dioxide. Carbon is a non-metal. Oxygen is also a non-metal, something like that. All right. Then an example of ionic bonding of sodium chloride, which is a table salt. Okay, sodium chloride. Then you also have metallic bonding. Metallic bonding, you should know that this is the bonding, the issue of the ions between metals. Okay, so that's it. You should also know the properties of a compound formed as a result of a chemical ionic bonding, as a result of covalent bonding, or as a result of what is this? Metallic bonding. And you should know how to draw the lattice structure of showing ionic bonding, something like that. All these, I'll answer them. In fact, I answered some of them, but there are others that I will post so that you just go through. Okay. That's it about bonding. Now, come with me to ionic equations. Number five, let me just write chemical equations. Chemical equations. Okay, under chemical equations, please know how to come up with a chemical equation from a statement or a reaction. Please do yourself a favor by knowing when they say, when dilute hydrochloric, for instance, dilute hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. Construct a balanced chemical equation, include state symbols. Where do you start from? You should know these by now, okay? You should know these and how to balance them. State symbols. Just on state symbols. Liquid, you may think liquid, they have no problem with liquids. But how to know that this is in aqueous state? That is why the problem. Let me tell you this secret, though there are exceptions. All acids are in aqueous state. When you say hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid, carbonic acid, all acids are in aqueous state. Know that. Are we together? Then, all bases are also in aqueous state, like sodium hydroxide. The most common use base is sodium hydroxide. In most of the exams, calcium hydroxide, potassium hydroxide, okay, a base, something like that. Then also salts. Salts, not all salts, by the way. There are some salts that are insoluble. I'm talking about soluble salts. I'll come to that point. I'll even write here salts. I mean acids, bases, and salts. You should know those. Now, balancing equations, you should know that. I have a video. It will be posted. I think it's already there. Okay. I answered a number about 20 questions, 20 equations. I balanced them. When you just follow the procedure and how we balance those, you have no problem. Let's go to the next point. Number 6. By the way, before I go to number 6, you'd also know how to write ionic equation. Because, listen, writing set symbols, aqueous state is very important, because if you don't know how to write, if you don't know that something is in aqueous state, it will be very difficult for you to come up with an ionic equation. Are we together? So number 5 under chemical equation, and you also include ionic equation. Number 6, acids, bases, and salts. And salts. Now, you should know the definition of an acid. The basic definition is these are proton donors. Now, but the definition is an acid is a compound which produces a hydrogen ion. Okay, hydrogen ion as the only positively charged ion in aqueous solution. Every acid has a hydrogen ion in it. Talk of hydrochloric acid, there is H. Sulfuric acid, there is H, hydrogen there, H2. Nitric acid, there is hydrogen. Ethanol, every acid has has a hydrogen atom, okay, ion, which is a positively charged what? A positively charged ion in the only positive charged ion in aqueous solution. Now, acids are divided into 2: organic and inorganic acids. Okay, organic acids, these are acids that are found naturally in plants, in animals, or even in animal materials. Okay, example, you have ethanoic acid. Okay, maybe I said ethanol earlier on, not ethanol, ethanoic acid, right? Ethanoic acid, methanoic acid, butanoic acid, tartaric acid. Okay, these are just examples, few examples of what even lactic acid, which is found in sour milk. Okay, in fermented milk, sour milk. You should also know where they are found, by the way. Okay, where they are found. Now, inorganic acids, they are also known as mineral acids. These are acids which are manufactured in the laboratory or in industries. You just react. A, B, so react. By the way, we're going to look at preparations of these acids. Okay? Don't be on pressure. Then you should know physical and the chemical properties of acids. You know that all acids stain blue litmus paper red. Okay? Acids have a sour taste, or they can burn skin. Okay? Yes, these are just the basics, and these are just the physical properties. Now, chemical properties. I'm interested in the chemical properties. If you know these chemical properties, some of the questions are answered in the chemical properties. Number one, acids react with bases to form two products, a salt and water only. Okay, salt and water only. For instance, hydrochloric acid reacting with sodium hydroxide to form sodium chloride and water. So it will be very easy when you just see a question where you have an acid and a base. It will be very easy even to come up with the products. The salt will be easy, and you even know what will be formed, that water will also be formed. Another chemical property is that, which is very important, is that acids react with some, not all metals, but some reactive metals to form a salt and hydrogen gas. Okay, and hydrogen what? Hydrogen gas. By the way, you should also know the identities of hydrogen gas, by the way. Okay, the other property, which is chemical property, which is very, very important, is that acids react with metal carbonates, okay, or metal hydrogen carbonate to form three products. Number one, to form a salt. Number two, carbon dioxide. Number three, water. So there are three products. Whenever you see an acid reacting with, let's say, calcium carbonate, as long as there's just the carbonate at the end, acid reacting with something carbonate, metal carbonate, or metal hydrogen carbonate, there are three products: salt, carbon dioxide, and water. Are we together? Now, you should also know bases. By the way, acids, you should know the difference between strong acid and weak acids. Strong acid and weak acids. That with strong acids, they ionize completely in aqueous solution. To ionize completely, let me just show you this quick example here. Visible this side, yes. Hydrochloric acid like this. To ionize completely, this will dissociate. It will be just hydrogen plus reacting with the Cl minus. This is aqueous, aqueous, aqueous. Okay, this is what it means to ionize completely. This acid is a strong acid because it ionizes completely in aqueous solution. Look, to show complete ionization, just to show one arrow pointing towards the products there. Okay, like that. Then weak acid. These are acids that partially ionize in aqueous water, in aqueous solution. Let me give an example ethanoic acid. Okay, ethanoic acid is CH3COOH. Okay, this is ethanoic acid. So to show its ionization, this is simple. I have arrow pointing towards the product and another one pointing towards the reactant, showing incomplete ionization. Only this hydrogen will ionize. So the product will be, let me just write from here, be CH3COO minus. And this hydrogen gas here. Are we together? This hydrogen gas will be dissociated. Why this one is a weak acid? Because some of the hydrogen atoms are still here in the compound. See? Simple. Now, you should also study base in the same way as acids here. Look at bases quickly. Run through bases. Look at the number of them, the differences between soluble base and insoluble base, the alkalis. Alkalis, know them. Are we together? Quick, fast forward. Know the, what's this? Know the pH meter, pH scale. To 7, 6.9, those are acids. Then 7, those are neutral substances. Then from 7.1 to 14, those are bases. Okay? Those are what? Those are bases. That's the pH what? The pH scale. Okay? Alright? pH scale. You should go through that as well. Now, quickly, this is still section B. of course. Section B. Number 7, also consider, very carefully consider the oxides. So consider the oxides. Types of oxides, know them. You should know what oxides are. That there are 4 types of what? Oxides. You have the acidic oxides, the basic oxides, the neutral oxides, and the amphoteric oxides. Now, the basic oxides, these are oxides of what? Of metals. Oxides of metals. Okay? Like, let's say you have sodium oxide. Sodium oxide, there's a metal, then there is oxygen on the other side. That is an example of a basic what? Of a basic oxide. Then you also have acidic oxides. Acidic oxides, these are oxides of what? Non-metals. Are we together? Oxides of what? Oxides of non-metals. Then you also have neutral oxides. Neutral oxides, by the way, examples of acidic oxides, you have carbon dioxide, nitrogen dioxide, to mention but a few. Neutral oxide. Neutral oxide here, you have, these are oxides that are neither acidic nor alkaline. Okay? Like nitrogen monoxide, okay? Carbon monoxide. These are examples of neutral oxide. Amphoteric. Let me even write this one. Low association of Zambia. Okay, I'll get back to that one. Amphoteric oxides, they behave like this. When they are reacting with an acid, they behave as a base. They behave as bases, as a base. When they are reacting with a base, they behave as acids. So they have properties, both properties, I mean. These are oxides that have both properties of acids and bases. Okay? Examples, we have this one, lead oxide, okay? Aluminum oxide, zinc oxide, okay? So sometimes in multiple choice questions, they usually ask, which one of the following is an example of an amphoteric oxide? Then you're given a list of them. Then lead oxide is there. Go for lead oxide. When there's aluminum oxide, just know LAS, Low Association of Zambia. Now, those are oxides. Know salts, by the way. You should also know salts. Examples of salts, preparations, by definition, how you prepare them. By the way, you should know soluble and insoluble salts. Insoluble salts usually come. Insoluble salts usually come. You should know the methods they are prepared and the process. Okay, the process, how they are prepared. All right. The issue of precipitation, neutralization for those soluble salts that dissolve in water. An example of an insoluble salt, a salt that does not dissolve in water, is barium sulfate, which is commonly asked, barium sulfate. So you should know the preparation of barium sulfate salt. Okay, let's proceed quickly. 8, periodic table. Please answer a number of questions on the periodic table. When it comes to the periodic table, concentrate on periodic table. At least know group 1 to group 7. Okay, 1 to 7. The other name for group 1, the chemical properties of group 1, group 7, group 1, group 7, and the group 0, which is group 0 or 8 or 18, which are noble gases. Okay, you should also know their special properties. Okay, their special properties. That is about the periodic table in general. Okay, periodic table in general. Remember, when you're writing the group numbers, use Roman numerals. Use Roman numerals. Like, let's say you want to say group 1. Write group 1 like this. That is the rule. That's how it's supposed to be. But periods you can write these, like period 3, period 4, but groups, right, use Roman Roman numerals, like group 1, group 2, group 3, and so on. Okay, you should know the alkaline metals, which are group 1, alkaline earth metals, group 2, the halogens. Why they're called halogens? Okay, because they are salt producers. They form salt. Halo means what? Salts. Genes to produce. So halogens, they are salt producers. It means salt producers. Then noble gases, you should know the meaning of noble gases. You know, they are also called minute gases, something like that. Also, take a little bit of time knowing the properties of each element in the group, especially helium, noble, argon, and neon. These three, know their special properties. Even xenon, the light I'm using here, the flashlight, there is xenon. That's just an example. But a bulb, argon, okay? Argon. Hot air balloon, helium. Those are the uses of those noble gases. Some of the noble gases, by the way. Now, I'm advancing. Let's now go, we're still in section B. Section B, number 9, is it visible here? Okay. Number 9, more concept. More concept. Now, when it comes to more concept, know how to calculate the relative formula mass, relative molecular mass. Okay, know how to calculate those. When you're given a compound, know how to calculate the relative formula mass, molar mass, something like that. Also, know how to calculate the mole to mole ratio, mole to mass to mass calculations. That is, when it comes to mass, volumes as well. You should also know those. Molarity, you should also know that. Concentration, yeah, something like that. When it comes to more concepts, also you should know how to calculate the percentage yield, percentage purity. The other thing which is very important as well is the what is this? Limiting reagents. You have a video, don't worry. I'll calculate everything I'm explaining here. After this, I'll post a video, okay? Video containing these, I'll be explaining. So stay tuned, okay? If you are still together up to this point, please consider subscribing, like the video if you are enjoying this journey, okay? The journey of chemistry. See, it's very interesting, right? Good. Now, let me just write from here, because here there is nothing. Number 10, you should also know the reactivity series of metals. In other words, know metals. Let me write number 11, nonmetals. And let me explain here. Guys, when it comes to metals here, you should know what metals are, the characteristic properties of metals, not only characteristic of properties of metals, but also you should know the reactivity series of metals. Because when you understand the reactivity series, it will be very simple to know the method of extracting that particular metal. Okay? When you know that, oh, the first 5 or the first 4 elements, they are most reactive. Okay? When you arrange them in the decreasing order or descending order, you start with the most reactive. So let's say you have potassium, sodium, lithium, something like that. Those cannot be extracted using any other methods but electrolysis. Okay? Electrolysis. Then from there, yeah. So this video is not for a person who completely know nothing about chemistry. So it's for someone who has an idea or someone who already know and he just needs a guide on what to follow, okay, for the forthcoming examination. After that, extraction of metals. No extraction of these important metals: zinc, iron, aluminum, and copper. Zinc, know the ores of zinc. The issue of calamine, zinc blend, how it is extracted, the processes, something like that. Please know that. Okay? Also, you should know, my good friends, extraction of iron, the use of the blast furnace, the issue of hematite, magnetite. Yes, okay, those are ores, but the chief ore is hematite. Okay, you should know that. From there, you go to aluminum. Aluminum, at least do a little bit of aluminum, because what is certain is that one of these comes in the exam, but we don't really know which one exactly. Okay, now know also rusting of iron, method of rust prevention like galvanizing, oiling, painting, sacrificial protection, something like that. Electroplating, something like that. Then let's go to nanometers. Nanometers here, we talk of the issue of, you study water. Water, the properties of water, identity tests for water. You should also know the uses of water, in the domestic use of water and industrial use of water. And at waterworks there, purification of water, how the domestic water is purified. Okay? The issue of filtration, sedimentation, chlorination, what, something like that. But there are two major stages involved at waterworks. The two major stages involved there are processes, filtration and chlorination. Very, very important stages. Now, quickly, you should also know, have a know-how under nanometers, preparation of ammonia, industrial preparation of ammonia, and also a laboratory preparation of ammonia. The issue of Haber process. You should also know Ostwald process, the industrial preparation of nitric acid. You should also know in addition, you should also know the industrial preparation of nitric acid. Okay, that is it's also a process, right? The contact process. Okay, the industrial preparation of sulfuric acid. Okay, now let's go to organic chemistry. I think this one will be the last one. Organic chemistry. What I've written here will not even spend time. I'll just give you the options, blah, 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 because they're here, already here. So organic chemistry, you should know the homologous, the organic compounds, the hydrocarbons, the alkenes, alcohols. You should know those. Polymerization, cracking. Okay, you should know the issue of nylon, terylene. At least have an idea of those things because they usually come. Okay, the other thing is rates of reaction. Rates of reaction. Let me even just come to section C here, because these are some of the questions that come in section C. Section C here, there are 3 questions you're supposed to answer. How many? 2 questions. 2 questions here. Usually, questions that usually come here, it depends. Extraction of metals. Extraction of metals. You should know one. Extraction of metals may be in section C or section B. Okay? Extraction of metals. Also, salts. Preparations of what? Salts. Number 3, non-metals. When I write 9 metals here, I mean preparations of ammonia, NH3, sulfuric acid, H2SO4, nitric acid, HNO3, okay, something like that. And also sometimes the periodic table, okay, periodic table. Salts there, then organic chemistry. Organic chemistry. It's 10 marks. So one of these, you find them. Oh, the last one, sorry, the rate of reaction. This is where now you even graph. Okay, sometimes you may be given a table, then you are asked, at what point is the reaction over? Sometimes they ask you something ending. What the factors that affect the rate of reaction? The issue of the temperature, surface area, pressure, to mention but a few. Okay, is usually in section what? Usually in section, what section is this? Section C. So section C, just go through these. You are safe. You are safe. So I think, now guys, we've come to the end of this video. I've just run you through the journey of chemistry from grade 10 to grade 12. Grade 10 to grade 12. So you can do yourself a favor by just going through. Okay. There's some, yes, I understand that there's some of the topics I've not included, important topics, but please concentrate on these. You will not be disappointed. Okay. Believe you me, you will not be disappointed. I love you all. Please consider subscribing, like the video. Bye bye. All the best on Monday.